192.168.10.0/24, which means with a subnet mask of 255.255.255.0. So it means that roughly or normally we can have two. Yeah, no, no, no. Now we move from the router to another thing, that is subnetting, that's related to IP addresses. Yeah, no, you will configure. By default there doesn't come. By default there doesn't come. Yeah. Hmm. Hmm. No, being a network administrator or network engineer of your organization, you need to design and implement that IP address configuration. But to design and implement that correctly, first you need to take up the requirements. You need to ask what are the organization requirements, what exactly they want. So first you need to gather those requirements. Based on that requirements, then you will design and implement those stuff. Well, we will come up later on. We have that example. Okay. So like here, as we are discussing the topic of subnetting, so you will know exactly what does it mean. So subnetting comes in once we want that we don't want to follow the uh, class boundaries, or you can say the default value of those classes as we discussed. So subnetting means dividing an IP addresses to further subnets as per your own needs or requirement of the organization. So think of, as we were discussing, that in this network we can have 254 computers that can be connected while using this IP address. So again, it is a one network and still it can work pretty much well. But in real world, you may divide such networks into small portions, in small, you can say, chunks of networks, because such large network may have issues, especially with the broadcast communication, or maybe you can say the collision which may occur in that network. So to overcome that broadcast or collision issue in such a network, we normally divide that large network into small portion, or you can say small network chunks. And to do that, normally we subnet the given IP address to custom subnets, means custom IP address. That's what we do normally in subnet to overcome that large network domain or that large one broadcast network. Yeah, IP address. Okay. Yeah, it will be customized using subnetting. Okay, so the same network is represented here with this example, as in previous diagram or image you saw it as a single network, but now here it is divided into four different networks. And remember, these two represent a router. So a connection between two routers also represent a network. So this is a router. So this is another network between two routers. So let's say 1, 2, 3, 4. Now that network is divided into 4 different networks depend on the organization needs and requirements. And what they do, they normally divide the IP address, subnetted the IP address. If you see the same 192.168.10 IP address is being used, but with different subnets, like here it is used 10.0, here it is 10.32, here we have the 10.64, and here we have the 10.96. So same IP address, but now the concept of subnetted. So now it is more flexible, more easy to manage, and the issue of a large broadcast is reduced here, and due to which there will be less collision in the network. So these are some of the key benefits of subnetting, which include reduce network traffic, optimize network performance, simplified network management, and even you can span a large geographical distance using the method of subnetting. So these are some of the key benefits, or you can say key, or you can say main points or objectives, that why we use subnetting in our networks. And to subnet, here is the thing, how to create subnets. So take bits from the host portion of the IP address and reserve to define the subnet address. So normally in subnetting, we borrow bits from the host portion and move them towards the network portion. That's how we perform subnetting, and that's the simple way you can understand as well that how we will subnet an IP address. So I will show you now, but remember, to perform subnetting you need to understand the power of 2. If 2 power 1, it will be equal to 2. 2 power 2 will result in 4. 2 power 4 will result in 16, and so on. So for subnetting purpose, and it's very simple, that's require a little bit of basics of mathematics. So that's important as well if you want to perform subnetting. Now, as we already discussed and talked about the subnet mask, so subnet mask normally define that what will be the network portion and what will be the host portion of IP address while you use a particular IP address in your network or in your organization. So normally that is being defined or identified from the subnet mask information. And if you recall the IP address classes, these are the default subnet mask for each class, for class A, B, and C as well. So 255.0.0.0 is the class A, then 255.255.0.0 is the class B, and then we have the class C, 255.255.255.0. So it is the class C subnet mask. And then also we discuss a simple thing about the classless inter-domain routing, that normally in real world we will type an IP address, and instead of writing the subnet mask, we type like this /28 /26, or let's say /29, etc. So that slash normally called the CIDR, classless inter-domain routing, and it tells that how many bits are on, means 1, and tells what your subnet mask is, means from this we can guess the subnet mask, or how many bits are for the network portion and how many bits left for the host portion. So if I take /28, so let's say we have a 32-bit IP address, IP version 4. So if we subtract 28, so how what will be the answer here if we subtract 28 from 32? Four. Yeah, so it means that 4 bits are for the host portion, these are for the host portion, whereas 28 bits are for the network portion. So that we can identify for the CIDR, means all 28 bits are on. In network we have the on bits, so all 28 bits are on, whereas the remaining 4 bits are for the host. So it is called the classless inter-domain routing. And simply if you type 255 255 dot I think 240 will be the subnet mask. Okay, yeah, so here you can see /28, you can see 240. So here for each CIDR value you have a corresponding subnet mask like this: /26, /24, /30. So we have all that corresponding subnet mask for each CIDR value. Yes, yeah, these are the CIDR values. So basically they show the network portion. They show how many bits are on, how many bits are on, and the on bits represent the network portion. Okay, okay, so here we have the class C address, and for the class C we have the simple decimal value, and in the CIDR value we can start from /25, /26, /27, /28, /29, and /30. Means already in class C we have /24. This is the default, but if we want to further subnet it, then we can start from 1-bit subnetting, 2-bit subnetting, 3-bit subnetting, 4-bit subnetting, 5-bit subnetting, and up to 6-bit subnetting. However, we need to keep 2 bits at last for the host portion, because these 2 bits will be for the host. But you can subnet in class C because it's easy to start from class C, not directly start from class A or class B. So it is simple to start from class C. So let's say I want to subnet an IP address of class C. So how you will subnet? Ask these 5 simple questions, but I will show you which 3 questions are mandatory, and if you know the answer of these 3 questions, you are done with subnetting. So first, how many subnet does the chosen subnet mask produce? Means how many custom subnetworks it will create. How many valid hosts per subnet? Means in each subnetwork how many IP addresses can be assigned to computers, and what will be the broadcast address and what will be the subnet mask. So these are simple questions. Yes, no, for each network, not for the router. This is the calculating the subnets, performing subnetting. So based on that questionnaire, let's show you an example.